Let us first take a 1-meter long channel and a small ball. Place one of its ends on the ground and hold the other end at some height from the ground. Now take the ball and release it from the upper end of the channel. Observe the velocity of the ball as it rolls down the channel. What do we observe? Was the velocity of the ball the same at all the points as it rolled down the channel? No. As the ball rolls down the channel, the velocity of the ball changes continuously. While rolling down the channel, initially the velocity is less. It increases through the middle of the channel and it decreases as it comes near the ground and finally becomes zero. From this activity, it is clear that the velocity of the ball changes continuously. As there is a change in the velocity of a ball on the channel, similarly, there is a change in velocity while sliding on a slide. While sliding down, initially the velocity is less. It increases in the middle and becomes zero towards the end. This rate of change in velocity is called acceleration. Acceleration is equal to change in velocity upon time. If the initial velocity is u and in time t, it changes to final velocity v, then acceleration is equal to final velocity minus initial velocity upon time. Therefore, a is equal to v minus u upon t. If the velocity of an object changes during a certain time period, then it is said to have accelerated motion. When the object is at rest at the start of motion, the initial velocity u is zero. Also, when the object comes to rest at the end of motion, the final velocity v is zero. An object in motion can have two types of acceleration: uniform acceleration and non-uniform acceleration. If the velocity changes by equal amounts in equal time intervals, the object is said to be in changes by unequal amounts in equal time intervals, the object is said to be in non-uniform acceleration. Come, let us understand more about acceleration. Positive, negative, and zero acceleration. An object can have positive or negative acceleration. When the velocity of an object increases, the acceleration is positive. In this case, acceleration is in the direction of velocity. When the velocity of an object decreases with time, the acceleration is negative. Negative acceleration is also called as deceleration. Its direction is opposite to the direction of velocity. If the velocity of an object does not change with time, it has zero acceleration. Zero acceleration is related to uniform motion. The motion of an object in a straight line can also be studied with the help of a graph. Let us now understand about the motion of an object in a straight line with the help of the distance-time graph and the velocity-time graph. Distance-time graph. A distance-time graph is a graph of distance covered by an object from the starting point against the time. In this graph, time is taken along the x-axis and the distance is taken along the y-axis. This graph is used to determine the position of an object at any time in the given time interval, to determine the speed of an object at any time in the given time interval, and to determine the average acceleration of the object. The Uniform and non-uniform motion of an object in a straight line can be studied on the basis of this graph. Come, let us study the distance-time graph in order to understand uniform motion along the straight line. Distance-time graph for uniform motion. We have studied that when an object covers equal distances in equal intervals of time, it is called uniform motion. Come, then let us now study the uniform motion along a straight line with the help of the distance-time graph. Distance is covered by a car in fixed intervals of time. The first column of this table shows the time in the unit second, while the second column shows distance in the unit meter. Let us plot a graph of distance against time, taking time along the x-axis and distance along the y-axis. The scale on the x-axis of the graph is 1 centimeter is equal to 10 seconds, while the scale on the y-axis of the graph is 1 centimeter is equal to 15 meters. Now let us draw the distance-time graph. What can we understand from this graph? Since the distance-time graph is a straight line, it is clear that there is a direct proportionality between distance and time. The straight line in the distance-time graph shows that an object covers equal distances in equal intervals of time in case of uniform motion. Now, can you tell, in this distance-time graph, what does the slope of the straight line indicate? The slope of the straight line in this distance-time graph gives the velocity of a moving object. After studying the uniform motion of an object in a straight line by the distance-time graph, let us now study non-uniform motion in a straight line by the distance-time graph. Distance-time graph for non-uniform motion. As studied earlier, we know that if an object covers unequal distances in equal intervals of time, it is called non-uniform motion. Come, let us study the non-uniform motion of an object along a straight line with the help of the distance-time graph. The given table shows the distance covered by a bus in equal time intervals. In this table, the first column shows the time in the unit second, while the second column shows the distance in the unit meter. Let us now plot a graph taking time along the x-axis and distance along the y-axis. The scale on the x-axis of the graph is 1 centimeter is equal to 5 seconds, while the scale on the y-axis of the graph is 1 centimeter is equal to 5 meters. Now let us draw the distance-time graph. What can you understand on observing this graph? Since the distance-time graph is not a straight line, we can say that there is no direct proportionality between distance and time. Here, the distance does not change uniformly with time. That is, it shows non-uniform motion. This is indicated by a curved line on the distance-time graph. After studying the distance-time graph, let us answer one question. What difference do you see in distance-time graphs for uniform motion and non-uniform motion? For uniform motion, the distance-time graph is a straight line. That is, in uniform motion, the distance changes uniformly with time. While for non-uniform motion, the distance-time graph is not a straight line. That is, in non-uniform motion, the distance does not change uniformly with time. Come, let us now study the motion of an object with the help of the velocity time graph.